Recorded on this computer. Okay, hi everyone. We're going to work on factoring large order polynomials today using synthetic division. Now, the example here I'm going to start off with is we're going to write x cubed plus 6x squared plus 11x plus 6. And you look at this problem and you're like, okay, what do you want me to do with it? And generally the idea is factor it. I want you guys to factor it. Write it is what times what times what times what became x cubed. Now, before we get there, I want to give you guys an easier problem. If I give you x squared plus 5x plus 6, could you factor this problem? Right? Could you factor this problem? And the way we factor these problems, normally we look at the last number. If this is a easy factoring problem, we look at the last number and we say, hey, look, the number 6. The numbers that become 6 is 1 times 6 and 2 times 3. These are the only possible values we can use to factor it, because any other number wouldn't multiply to become 6. Let me give you an example. If I chose 4 and 7, well, 4 times 7 doesn't give you 6, so I know for sure 4 and 7 isn't a possible combination, right? That's just legit crazy. But if I got 1 and 6, 1 times 6 is 6. Or if I chose instead 2 times 3, the back times the back would give you 6, right? These are my only possibilities. Now, which of these options add up to 5? Well, 1 plus 6 is 7. That's not 5. But 2 plus 3? Yeah, 2 plus 3 is the 5. So we said 2 plus 3 has to be my values for my factor. And it's plus plus is plus plus, right? So this is how we were able to factor x squares. But x cubes, unless it's factored by grouping, we weren't able to factor this. So this is where synthetic division comes around. And the key point here is the division part of it. Now let me give you another problem, okay? If I give you a number 3, 2, 1, and I ask you, hey, what numbers are the factors of 321? And you're like, hell if I know, I don't know. So what you do normally in 4th grade or 5th grade or even 6th grade, you say, I'm gonna start dividing numbers into it. And we could divide this number 3. 3 goes into 3 one time, 3 goes into 21 7 times, so it's 107. So 321 is really, the factors are 107 times 3. To work on an easier version, if I gave you the number 24, how would you divide 24? If I asked you what are the factors of 24, you would first start dividing values out. You would say, hey, divide 2, that gives me 12. Divide another 2 gives me 6. Divide 2 and gives me 3. So the factors of 24 are 2 times 2 times 2 times 3. So we use division as our main way to factor numbers that were just simple constants before. We use division, right? It's hard for me to think of what times what, especially as a number I never heard of. So we use division. We start skimming off numbers. And as we skim off numbers, the problem becomes easier to divide. And that's actually what we're going to do here. We're going to start skimming off polynomials, so x cubed becomes x squared, and then we can factor it easier. So let's go ahead and demonstrate this right now. First things first, you want to write down all the possible values that we could try. So we look at the last number just like we did here, and the numbers are going to be 1. So we can call these k or r, it's up to you. Let's call them r right now. R is going to be, it could be 1 times 6 or 2 times 3. These are my only possibilities. If this was factorable, these are my only possible numbers. And they're plus and minus. I don't know is a positive or a negative version of it. Okay, so that's a hint. I don't know if it's going to be a 1, a negative 1, a positive 1, a positive 2, a positive 3, a negative 3, a positive 6, negative 6. It's one of these combinations. If this is factorable, it's going to be only one of these 4, plus and minus. So a total of 8 possibilities. And what we're going to do is we're going to use synthetic division to actually try it. Okay, to actually try it. Now, if I gave you 321 and you tried dividing by 2, you would realize you would end up with a remainder and you weren't going to get it. So this is our hint. We're going to end up with a 0 remainder when we do synthetic division. So let's go ahead and demonstrate what we're going to do today, right now. And just to kind of soften the blow, on your My Open Math work today, they will give you a hint of what number to use. Okay, they will tell you, use 1, use 2, use 3, use 4, use 5. They'll tell you what number to use. So you're not going to have to guess it right now. But I'm going to teach you the whole lesson where you're going to check them one by one. So let's go ahead and try this. we're going to try positive 1 first. So we set up synthetic division, 1, 6, 11, and 6. Right, 1, 6, 11, and 6. Just to make sure this was right, 1, 6, 9, okay. And here's what I want you guys to write. I want you to say, hey, if this is factorable, I'm going to try x plus 1 there. All right, I'm going to try x plus 1. So to use synthetic division, remember we wrote the factor in the corner, what we're trying to divide by, our factor. And what number do we write here? Are we going to write positive 1 or negative 1? Remind yourself, are we going to write positive 1 or negative 1? We're going to write negative 1 here because negative 1 plugs it in. On My Open Math, they will tell you what number to write in this corner here. They'll tell you which one to use, okay? Now we use synthetic division. Go ahead and use synthetic division. Run the course, run the gauntlet. Negative 1, no, sorry, that's positive 1, I'm sorry. This is 1, multiply up to become negative 1. Once you guys do the rest right now, I'll give you guys a head start of 5 seconds. And you guys should probably be done in 5 seconds. Okay, 6 minus 1 is 5. Multiply up to become negative 1. That becomes 10. Whoops, did I make a mistake someplace? Oh, this is 5, I'm sorry, I don't know why I wrote that. This is 5, this is 6, this is negative 6. We end up with 0. That means a 0 remainder, 0 remainder. And that means that x plus 1 was a factor hidden inside x cubed. What's left over? Let's rewrite our x, our 1, 5, and 6. That's x squared plus 5x plus 6. Hey, check this out, folks. We know how to factor this. The goal is once we get to x squared, we're back to algebra 1 and algebra 2, and we can use our factoring skills to factor this. We can factor this to become x plus 3, x plus 2, or you can write it the other way, x plus 2, x plus 3. Now, I want to stress out this point. What are the factors of x cubed plus 6x squared plus 11x plus 6? We see that it's going to be at least these two, x plus 3 and x plus 2, but also x plus 1. By using synthetic division, we are able to cut out one of our x's, leaving us x squared, where we can go back to our algebra 2 skills and factor it by hand now. No synthetic division needed. What about the rest of the 1, 2, 3, and 6? What about these options here? Remember how I told you our factors could only be these numbers? Could only be these numbers? Please take a look. We said 3, 2, and 1, and all 3, 2, and 1, all 3, 2, and 1 are 3, 2, and 1. These are all the possibilities that we said could have been possible. 6 wasn't it was a possibility, but it wasn't an actuality. Okay, so take a look here. I think it's kind of cool, right? Kind of a cool way of looking at it. Hey guys, let's go back and talk about this. My possibilities were 1, 2, and 3. And it turns out 1, 2, and 3 were values here. Okay, we don't end up with a random one that wasn't listed here. If this was factorable, these are my only options. Okay, what if I picked another number? What if I picked 2 instead? Okay, if I picked the wrong number, one number that wasn't a factor. So you guys don't need to copy this, but take a look. What if I just picked the wrong one? What if I wrote positive 1 instead? The factor would have been x minus 1. As you can see, x minus 1 was not my answer up here. What would that have looked like instead of synthetic division? 1, 1, 7, 7, 18. Oh, you can see right now it's not going to cancel out. So what happens is this was dead, a dead end. The goal is to get 0 here. This is the goal. The goal is to get a 0 here. A 0 remainder means this was a factor. This was not going to go to 0. So what do? We scrap it and we move on. Now, please do not erase your work. I want to show you the trick. Take a nice eraser and just erase the bottom and the middle line, and you're good to go again. You can erase the front and this value here, and we can try another number. Now, I'm going to give you guys another problem now, and this other problem, we're going to have to search for it, okay? We're going to have to search for it. Okay, so let's do another problem, and we'll see how synthetic division is going to work out for us here. X cubed plus 3x squared minus 4x minus 12. Okay. So if I'm asking you guys to factor this, and I'm telling you this is going to be factorable, okay? The numbers, the problems so far that I'm giving you are going to be factorable. I want to ask you guys, what are the possibilities if this was factorable? What numbers would work? What numbers make up 12? It's 1 times 12. I'll give myself some space. It's 2 times 6 and 3 times 4. Oh my gosh, Mr. Go, there's so many possibilities. You're right, there's so many possibilities. Okay? But at least it's not an infinite many set of possibilities. It's not like it's any random number in the universe. It's only these. And we won't even go through all of these when we're checking. So I'm going to show you guys how we're going to check each individual number till we hit a winner. Okay, it's almost like the lottery. We're going to pick random numbers, but we're going to go in order and we're going to hit a winning number. And this is a guaranteed win for us. Okay, so first step, plus and minus, right? Plus and minus. Remember, these could be positive or negative. And I'm going to set up my synthetic division. Here we go. Synthetic division. 1, 3, negative 4, negative 12. And I'm going to try the number 1 first. The factor x minus 1. Take a look. If I plug in 1 here, the goal is to get 0. That is the goal, everyone. My goal is to get a 0. 0 remainder means this number was a factor of it. Right? Right, here we go. First one's free on me. 1. Multiply by 1. 1. 4. 4. 0. Am I going to get to 12 here? Nope. So we end up with negative 12. This is a fail. We picked the wrong number. Oh no, we wasted time. No, we didn't. We didn't waste time because we were able to say, hey, we know that 1 is not a root and x minus 1 is not a factor. We at least got rid of one possibility. So take a look here, get your eraser, lightly erase the bottom and the middle term. That's it. And we're going to change, take a look here. You see, it's almost like we reset it. You don't have to write a whole new set. Don't do that. No, 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 please don't do that. We're just go back to the original one, and I'm going to make this a negative 1 and a positive. Take a look. I'm just going to flip those signs. We tried positive 1. It did not work. It's okay. We can move on. Mr. Go, this is so much work. You're right, because this is a harder problem than 3rd grade math, right? So we're going to have to try some techniques. It's just like when you're learning a new skill. You try it, you fail, you try again, okay? Here we go. Let's try negative 1. 1, negative 1, 2, negative 2, negative 6, positive 6. Nope, not going to work. Darn it. Darn it. We failed twice. So at least we know right now. So take a look. I'm going to go ahead and cancel so you guys see. 1, oh, darn it. Wrong color. 1 is not a factor in this problem. Okay, here we go. We tried 1, didn't work. Then let's try 2. Please don't go 1, 12, 2, 6, 3, 4. Go in order, okay? So you don't lose your place in line. And 12, highly unlikely. 6, highly unlikely. That large numbers are probably not going to be it. Like 80% of the time, 95% of the time. Making up numbers here. But most of the time, well, they will not be it. So we start with the low numbers first. Okay, 1 doesn't work. Let's go and try 2 now. Here we go. I'm going to use red now. 2. Let's try negative 2. I have a negative sign there. That's right, negative 2. And we'll just change that to a positive 2. See that? Negative 2 plus 2 is 0. So erase it a little bit. Try different numbers. You can always choose whichever numbers you want. I'm just going to go from 1, 2, 3, 4, 6, 12. I'm going to go that way. And positive, negative is up to you. Here we go. So 1, negative 2. 1, negative 2. Okay, I'm not sure if it's going to work. Negative 6. Positive 12. Woo! We got a 0. Winner, winner, chicken dinner. Winner, winner, chicken dinner. Why am I so excited? Because we found a value that worked. And that means we have less work to come. So What I want to point out that we know now that x plus 2, you are a contestant on The Price is Right. Come on up. X plus 2, you are now a factor. Ding 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 ding. I don't remember how the song goes. So it's x squared. What's left over? We went from x cubed, right? X cubed to x squared plus x minus 6. All right. Now if it's x squared, we can factor this by hand. What numbers multiply to become 6, but subtract to become 1? 1, 6, 2, and 3. Which of these possibilities multiply to become 6, right? 1, 6, and 2 and 3. These all multiply to become 6. But which of these possibilities subtract to become 1? 3 minus 2 become 1. Here we go. Let's write that out. X, 3, and 2. We need more positives to win, and negatives lose. We need that negative because we have to multiply to become negative 6. So we have found all our values. I'm going to rewrite this as x minus 2 and x plus 3. We have found all the factors we need to. We are winners. Yes, we are winners. Okay. Whew. That seems like a lot, right? Okay, so let's go ahead and do this again. I'm going to give you guys one more step here. Okay, so I'm going to make an even larger number here, and I'm going to show you how impossible this looks. X to the 4th plus 4x cubed minus x squared, that looks like terrible, x squared, minus 16x minus 12. I'm going to double check in case I always copy things wrong. I don't think I'm dyslexic, but sometimes I feel like I am. Just rewriting that. That's a nice x. All right, okay, so we're looking at this problem here. Now, what are the possibilities? Now, I can't just factor x to the 4th. I'm not a genius. I'm not superhuman. So I'm going to use my tools. And I'm going to say, hey, what possibilities are there going to be? So my R values can be 1 and 12, 2 and 6, and 3 and 4. I'm writing them out so I can see on the table what are all my tools. What are all my possibilities? Don't forget to write plus and minus because this could be a positive one or a negative one. I don't know. I don't know. Okay. Let's go ahead and write our synthetic division. It's not going to take me much time. 1, 4, negative 1, negative 16, and negative 12. Be careful about these negative signs, right? These negative signs do count. They do matter. They do matter. They do matter. You guys matter. These matter. All right, so what do we do? What numbers do you guys want to try first? We know 1, 2, 3, 4, 6, and 12. They're all possibilities. Do you guys want to start with 12? Do you think it's going to be a huge number? Are you going to bet it's going to be a huge number? Are you going to shoot for the moon? I'm going to instead choose 1. And in this case, I'm going to choose a positive 1 here, okay? X minus 1 is my factor. Double checking, 1 minus 1, right? If I use positive 1, the factor would be negative 1. X minus 1. So real quick, 1, 1, 5, 1, 5, 4, 4, negative 12. Negative, so close. My frustration is real. It was so close. So close. I even double checked it right now. So close. So close, folks. You guys see how it's so close? Negative 12 and negative 12? Oh my gosh. If that was a positive 12, we would have been done here. But no. Robin Hood refused to sell. I'm sorry, excuse me. Okay, so it didn't work. We gotta regroup. It's okay. Let's try a negative 1 now. If negative 1, our factor is a positive 1. Double check that. If I use a negative 1 plus 1, that will cancel out nicely. All right, so let's go ahead and try it now. Here we go. 1, negative 1 becomes 3. Negative 3, negative 1, negative 4. Positive 4, negative 12. Okay, we'll look like, well, don't get too excited. Negative is a positive 12. Woo! Winner, chicken dinner. Okay? So our goal is to get that 0 remainder because now we know we are on that next level now. So I'm going to write this for you guys on the side here. This is going to be x to the fourth. So x to the fourth when we first started. So we drop one, x cubed plus 3x squared minus 4x minus 12. But oh man, this is x cubed. I still can't factor x cubed without help. Okay, I still can't factor it out without help. So let's try something. We're going to go at it again. So we're going to start here. Okay, one more time. Okay, since we're in x cubed and we're not x squared yet, we're going to go one more time. Now, you might notice that this is actually the last problem that we had. Okay, that's the last problem that we had. X cubed plus 3x squared minus 4x minus 12. That was the last problem that we had. Okay, FYI, that was the last problem that we had. So since we know what values will work, this is what you do. So take a look at what I did. I didn't redraw. Nope, I didn't redraw. That would just waste my time. I already have it set up here as synthetic division. So we draw a little box and we go one more time at it. Okay, one more time. What number should we use? Take a look here. You can use any number you want. You can either use a -2, you can use a +2 or a -3. Okay, these are the zeros. You can use a -2, +2, or -3. Which one you want to use? You can use any one you want since we already know what the answer is. I just want to show you, if we didn't know, we would actually have to test it again. Now, just FYI, once we know that -1 is an answer, it doesn't mean it couldn't be a possibility again. We could try -1 again, just in case our numbers repeat, and that's called a multiplicity. When you hear the word multiplicity, that means the same answer repeats over and over again. Okay, that's just a keyword we'll look more into later. Let's use the number -2 like we did before. So let's go ahead and write the factor. It'll be x plus 2. Are you guys okay with the factor? That's my polynomial, my binomial. So 1, -2, right? 1 times -2 is -2. 1 times -2 is -2 again. -6 times -2 is +12. And we are at 0. Winner, winner, chicken dinner. And we end up, like we said before, this is factorable. 6 times 1 or 2 times 3. Once you get x squared, do not do synthetic division anymore. It's a waste of your time. Honestly, it's a waste of your time. Let's just go ahead and use algebra 2 skills and factor. We said 3 times 2, x plus 2, x plus 3, and x minus 2. Now, how would you write the official answer? It all depends on what the question is. If the question is, please factor this polynomial up here, please factor x to the fourth, our answer, our factors are x plus 1, x plus 2, x minus 2, and x plus 3. We need all 4 of these factors to get to x to the fourth. And that's why synthetic division is super helpful to us. It gives us this huge polynomial and say, hey, go get factoring, break this apart. And it gives us an easy tool to then divide out one factor at a time. Though oftentimes it's guessing, but let me again reassure you, you've been guessing your whole life. Okay, you've been guessing when I give you a value 1, 1, 2, 1, 1, 2, 2, right? If I ask you, please factor out this number, 1, 1, 2, 2. Okay, how would you factor it out? You would start dividing small numbers. You divide by 2. 2 goes into 11, 5 times remainder 1. 2 goes into 12, 6 times. 2 goes into 2 one time. And then you would say, hey, let's divide this by 2 again. Can I divide 561 by 2? Nope. So you try another number, maybe 3. Can we divide 561 by 3? 5 plus 6 is 11, plus 1 is 12. You can divide 12 by 3. Yes, you can divide this by 3. Oh, 3 goes into 5, 1 time, remainder 2. 3 goes into 26, 8 times, that's 24, remainder 2. 3 goes into 21, 7 times. And I think we are stuck with 187. So 187, because I can't divide this by 3 anymore, and I can't think of another number I can divide this, times 2 times 3. These are the factors of 1122. Okay, so we have been doing this skill of just dividing, but in this case we're using synthetic division as our dividing tool for large polynomials. Okay, so let me pause here for a moment. So I've logged into my Open Math, and this is your problem on one of your homeworks. You have 12 questions total. So let's talk about how you would solve this problem, okay? The thing is they told us that factor the following expression completely given that one of its roots is 7. So we know what one of the zeros are, okay? So let's go ahead and do this together. We're going to set up synthetic division. I see a 1, 3, negative 49, and negative 147. 1, 3, negative 49, and negative 147. Because we know, we don't know. We're going to use synthetic division here, but we do know that our answer is going to be 7 here. What's the factor? The factor is x minus 7. Remember, 7 minus 7 gives us that 0 we're aiming for. Okay, so here we go. 1, 7, 10, 70. Okay, 70 minus 49 is 21. And 21 times 7, which I have no clue, but it looks like 7 times 20 is 140. 7 times 1 is 7. All right, winner, winner, chicken dinner. So the idea here, the first couple questions, they will actually give you a couple of roots. So you can use synthetic division and break that down. We're left with, starting from x cubed, we are left with x squared plus 10x plus 21. We can factor this. We can factor 21. That's 21 times 1 or 3 times 7. Which of these add up to 10? Well, that's 3 and 7. X, 3, and 7. And the plus plus is plus plus. So please be careful. We want to go back now. We want to go back now and answer the question. Factor. Okay, that means they want all the parts back. Not only do they want x plus 3 and x plus 7, they also want x minus 7. X minus 7 was actually in our problem here. So on IXL today, this is what you guys are going to be working on, skills like this. And there's a couple of different skills that they're going to be asking for, but all along this line of using synthetic division to find the roots so that you have the factors. And then we can factor it. Okay. Let's go and look at the next question. Next question is very similar. Look, they told you the root is 8. Great. Nice. Told you that they're telling the roots. Now this one here, they did not tell you the roots. Now question 4 here, they do not tell you the roots. That means you have to then look for those roots. Which of those possibilities would be the roots? So you might be guessing a little bit, guessing a couple of times, but that's part of the skill. Let's go ahead and try this, and let's see how many steps it's going to take us to find this answer. Okay, so the possibilities for 280 seems like it's a lot. Okay, it's a lot. I get it. It's a lot. But let's go ahead and find. Say our R values are 1, 280, 2, 140. Does 3 work? Yes, 3 does. Oh, no, it doesn't. 3 plus 8 is 10, and no, 2 plus 8 is 10, and so 3 does not work. Does 4 work? If I divide 280 in my head quickly by 2, is it going to be even? 240 is 140. Yes, it's going to be even, so we can do 4. So 280 by 4 is 60. That's 24. Remainder 4, 68. No, I'm sorry. 6. Well, I'm sorry. That's not right. You could divide it. 4 goes in 27 times. That's 70. 5 for sure works. 280 divided by 5. That for sure works. That's 25. Remainder 3. So it's going to be 56, I think. Okay. Sorry, I ran out of space. 5, and we said 56. We can do 10 and 28. And I think that's a good place to start. It's a lot. So 280 is a huge number, so there's a lot of possibilities. If you want to start off with a couple, it's a good place to start. Right? But these are all our possibilities, I think. 11, 12. 12, nope. 12 needs a 3, right? We don't have a 3. We do have a 4. 15 needs a 3. So, okay, I think we are in a good spot right here. So we write our synthetic divisions. 1, 4, negative 61, and negative 280. Those are really only 4 steps for us to check. Now I'm going to check starting from 1. Plus and minus, I don't know if it's plus or minus 1. Let's go try positive 1. My factor would be x minus 1. And here we go, starting with 1. 1, 1, 5, 5, negative. Now over here, I can actually really see that it's not going to get up there, is it? 280 is really a big number. And me multiplying by 1 is not going to get me anywhere close. So I'm thinking 1's not going to work. And negative 1 for sure is not going to work. Because by the time we combine it, it's not going to be close enough. So let's jump to 2. Use a positive 2 here, and we'll see how it goes. 1, 2, 6. Okay. 6 times 2 is 12. 12 minus this number doesn't look like it's going to be big enough to fight 280. So once I realize it's not going to work, I can move on to that next number. Erase, erase. And then I'm going to change this to a negative 2 and a positive 2, right? That's my factor. So this is first one free on me. That's 1, negative 2, 2, negative 4. And then I'm going to get negative 65. But negative 65 times 2 isn't going to be close enough to 280. So 2 is not going to work either. Negative 2 is not going to work either. Let's jump up to the next one, 4. Here we go, positive 4. As you can see, it's taking me about a minute per try, if not a little bit less. If I wasn't talking, I would just be machine gunning this. And this is not positive, this is going to be a minus, right? So 1, 4, 8. 1, 4, 8, 32. And this is going to be a 29, I think, negative 29. Is that right? 50, yeah, 29. But 4 times 29 isn't close enough. Darn it. Ugh. Close, but not close enough. And now I'm going to try negative. Negative 4 and positive 4. Now again, I'm going through this one at a time because I don't know which one's going to hit. Right? I don't know which one's going to hit. But at least I have a process of working through one problem at a time. Now, you might say, Mr. Ko, how about on the test, right? Are we going to burn a lot of time on the test? You could. Honestly, you could. But the test will have less questions than a typical test because of stuff like this. Okay? And oftentimes, I will include a hint. So 1, negative 4, that's 0. Okay, 0 doesn't look like it's going to be good already. 0, negative 61. And this is going to be 248. So, nope, doesn't look good either. 244. So, nope, not good enough. All right, let's move on. Next one. So let's try 5 now. I think I did the other version, negative 5. Okay, here we go. 1, 5, 9, 45. And this is going to be too small. I think it's going to be too small. 5. Yep, it's going to be too small to hit here. So move on, next one. Negative 5, positive 5. 1, negative 5. This becomes a negative 1. Negative 1 up here becomes a positive 5. This becomes a 56, I think. 56, negative 56. Right, and then if I multiply negative 56 by 5. Okay, negative 56 by 5 is 25. It's going to be a positive 280. Oh my gosh, we finally hit it. We finally did it, everyone. We finally got there. Oh my goodness, we finally got there. Wow. Okay, so we found one. Now, we now have x squared minus x minus 56. Oh, I actually did forget one. I did lose one of them. So what numbers multiplied to become 56? So now, once we get to x squared, we can factor by hand. What numbers multiply to become 56? That's 1 and 56, of course, and 7 and 8. And does 7 and 8 subtract out to become 1? Turns out these are my factors. X, 7, 8. And we're looking at more negatives than positives. So the final answer here is actually x plus 5, x plus 7, and x minus 8. All right. We were able to factor it, not knowing any clue where to start, except 1, 2, 4, 5. It turns out I missed out. I missed out on 7 and 8, didn't I? Never would have known that. Okay. All right. So your homework will be consisting of stuff like this. Most of the times they will give you a hint of what number to try, and when they don't, you have to come up with these numbers yourself. All right. That is factoring using synthetic division.